Oh, sweet, free post-its.
Why
Why are you wearing a blue jacket with black pants?
Don't want to. Don't have a black jacket. They don't let you wear black jackets at school.
Hey, your baby ties. Oh, Patty Wumpus.
It's not a baby tie. It's not called a baby tie.
It's such a baby.
That's a grown man tie. I'm a grown man.
No, the one that's under it. The one that always peeks out.
I've never heard that it's a baby guy. The little one? Wait, can he?
I made it up. I had a little powerhouse under my bed. I gotta get my
That's a
homework.
baby tie.
It was so cute. No, the tie that's under the big tie.
know.
I lost it too.
Haley, what the heck did you do to your book?
You don't want me to
It's like beaten up every day.
Wait, homework.
Yeah, it's like a
I did it. I just lost it.
Wait, say that one more time. She wants to die, so she figures out that she's black.
I did it. Hold on, let me write down these problems so I can read it.
Oh, that's
It's awful.
Anna Payton.
I didn't know how to do number 4.
Like 30 pages of depression.
Amy did the, I didn't grade.
Wait, you already graded mine.
Nobody did this one. Was it nothing?
No, you had to factor it out before. I did it, I just lost it.
Wait,
Can we go over
you already put 100 by mine though. I did. So that was it there.
I knew it.
You what?
Just for problems
I bought it.
that we did.
When I bought it. Dot.
Tell me what you got, and we're gonna we're gonna start with review of all the ones with 2.
So it is mine's on the back of it.
This one must be bright though.
So it is mine.
These never keep up.
They don't.
We'll call on the board on Friday, or Saturday, or Monday.
Oh, here they are. There you go. It's got another work on the back.
What's everybody got? A lot to grade and I don't know. Alright, so let's start with a couple of problems from the 2 problems. So we're going to do a couple that have 2 terms to practice out, and then we're going to move on to 3. Luckily for you, the ones with 4 are actually the easiest, so that'll be what we do. Don't plan in tomorrow. I don't really too much. It's more like because there's just less you can do to them. 3's the hardest. 4's the best. Alright, so let's say I have this. Here's 2 terms. Is this what we've been doing? Yeah, we're starting with a review of some that have 2 terms. 19 minus 27. What do we always do first?
Factor.
No, we get like terms. Yeah.
Yeah, that's what I said.
Yeah, so I can take out a 9. And you're right, there just aren't any.
Oh, man.
Okay, now I'm going to look at this to see if it can be factored further. Did you see there's no t squared in there?
Yeah.
It's not squared. This is not. What we're factoring, it's not written on there, but what we're factoring are quadratics. That's a fancy word for something whose degree is 2.
I know the 4th degree. Squirtic. I was gonna name my son that.
There was a movie where the guy had named all this, so they like promised the goodness.
Tertius.
Tertius. This is not like a robot on like royal family.
Wait, why did you do that? That's
So,
son to
what's left
first.
in here is not quadratic. We're finished with it. There's nothing else that can be done. It's not a difference of squares. Neither one of those is squared. It's not a difference of cubes because neither one is cubed, so we're finished. Sometimes the greatest common factor is all you can do. Alright, here's another one with 2 terms. First thing we should do, there's no like terms. Is there anything we can factor out?
Yeah.
No.
Yeah.
It looks like there should be, but there's not.
Wait, they're both pretty square.
They are both perfect squares, so we can factor this with our difference of squares rule. What is the square root of 16x squared?
4x.
4x, so it goes in both of them. I get a plus in one and a minus in the other, and then what goes in that second spot? 9, because that's the square root of 81. Y'all are getting good at these too.
Thanks.
Alright, here's another one, 3y is up
Wait, can't you factor that more? The 4
Because the x is not.
never
How?
mind.
Yeah, it's because it's not square. You're right, those are both, the 4 and the 9 are both squares, but the x is not, so we're finished with that one. Way to keep looking.
Oh, thanks.
There's no like term. Is there a greatest common factor?
Yeah, 3.
Or is there a greatest common factor other than
3y.
Ooh, 3y, even better. Then what we have left is y to the second minus 9.
And then that's the very.
This is why this one is tricky, because when you glance at it, it looks like a difference of cubes. Because 27 is a cube and there's that y to the third, but it's not. Once we take our greatest common factor out, we find that what's left is a difference of
Squares.
squares. So I just keep my 3y, it comes along for the ride, and I write my 2 parentheses. What goes in the front?
Y.
Because that's the square root of y squared. Plus in one and minus in the other.
3.
3. You can pretty much tell you're finished when you don't have any squares left. There's usually nothing left to do because those aren't quadratics anymore, but glance at them. We're finished with that one. Make some good notes. U to the third. Is there anything we can factor out? No. One has p's and one has q's. There's nothing, this has all 2's as factors and that's got all 5's. Nothing's going to come out of there. So look at the rest of our list. Does it meet any of those 3 rules? It's a difference, not of squares, it's of cubes. So we've got to take the cubed root of each one. Our signs go minus, plus, plus. It always ends with a plus. The first one is always matches, the second one is the opposite, and then it always ends with a plus. Alright, and then we put, right here goes the cubed root. What's the cubed root of this? 4. 4 is 16 times 4 is 4.
Each of those.
Can we all whisper it? Like, maybe if you're wrong, everybody's going to be like, hey, you David. But we're not going to say that because we're nice to each other in this class, alright?
Wait, why is it P
Oh,
and not P to the third? Because.
Because we're taking the cubed root.
Oh, yeah, yeah.
Because P times P times P is 3. Alright, what goes here? 5 cubed. The cubed root of 125 is 5. Again, if you are unfamiliar with how to do that on your calculator does cubed roots. If you don't know how to do it on yours, ask me when we get to the time, because everybody's is different. So just ask me when we get to that part of your work, and I'll be glad to show you how to do it on yours. Because then it's a quick way to check if that's a perfect cube or not. Some people don't immediately recognize them. So if you want to check, I'll show you how to put it in and make sure. Alright, now what goes here is, we take this thing and square it, so we get
16p squared.
16p squared. That's how you got to on the wall later. Alright, and in the last spot is where we put this thing squared.
25p squared.
25q squared. We're ignoring that minus because that's part of the formula. So we're not worried about signs at this point. Those signs come straight from the formula. So minus, plus, plus, and we don't have to worry about, wait, is it a positive when you square it, or because these are all coming from the rule. So that's sort of a good thing. And in the middle, what do?
You add the things,
Plus.
something like that.
multiply the two together. So, 4 times 5 is 20. And then p cubed, because those just get crammed together. They're not leaving enough space next. So we take the cubed root of each, and then in the second set, square the first one, square the second one, and in the middle, multiply them together. So what you're doing is multiplying this thing by itself, multiplying this thing by itself, and in the middle you multiply the two together. Let's do one more with 2 terms, if I can find my eraser. There's no like terms. Is there anything we can factor out? I like that you're looking at it quickly. No. Nothing we can factor out. This one has y's and that one has x's and those aren't the same. Does it meet any of those 3 rules? Yes. It's a difference, because there's a minus here. A difference of cube. So I'm going to have 2 sets of parentheses. I'm going to start with a minus because that matches. Then the opposite, then we always end with a plus. In the first spot I put the cubed root. What's the cubed root of y to the 6? It's y to the second. That came from 6 divided by 3. Why 3? Because I'm doing the cubed root. Y to the second times y to the second times y to the second would be y to the second. Alright, and then what's the cubed root of this bit? 2x. Alright, so now square this thing. Y squared squared is y to the 4. And then in this end we square this thing, so we get
4x squared.
4x squared. And then in the middle is where we multiply them together. So 2xy squared. How do you feel about those in general?
Yeah, good. I feel like I can do it when you help us.
Yeah, same.
If I'm looking at this thing, I can do it just because I don't know all the formulas quite
You'll
yet.
get there. That just comes from practicing them, and I'm not in a big rush. We're going to get this. So if it takes us a while, it takes us a while. But what we were talking about, when's our next test? Ben asked me about that, and I said it kind of, not this week, because tomorrow's the last chance we have. But next week is the last week before Thanksgiving. So if we don't finish this chapter, we're just going to stop and quiz on however far we got. Because I don't want to leave a test over the break. So, there's actually, just not doing it the same way the book is. They kind of mixed all these up, and I didn't like the way they did it. So, we have the equivalent of 2 sections left to go.
We have 1 more week until Thanksgiving.
Hmm?
1 more week until Thanksgiving.
Next week is our last week. I mean, we have the rest of this week and then all next week.
Dang.
How are we doing? Time to do trinomial. All we're doing under there for now is what's called reverse FOIL or modified T. So we're going to learn reverse FOIL, and then there's a shortcut called modified T, but I have to show you reverse FOIL first because that's how we learn. Okay. Let's say we have this. So I'm going to ask for this first example, I'm going to ask that you just please watch. Because I want you to be able to pay attention without writing down. There'll be plenty more examples to write down. So here's what I have, and I'm going to FOIL it out. X times x is x squared. X times 4 is 4x. 2 times x is 2x. And 2 times 4 is 8. And then I put my like terms together. So that's how I got this little quadratic. But now, I want to go backwards, because that's what we're doing when we're factoring. And I want to figure out what I've started with. There's not quite the same kind of formula for this one. We're kind of going to have to use some creativity. And here's what makes it tricky, is we have to figure out what 2 things were added together to get the 6x. And that's kind of difficult to do when you're going backwards. So that's the trick of this. So the first method we're going to learn is called reverse FOIL. So we're going to take the problem. Now we already know the answer, but just for a minute we're going to pretend we don't. We know that the answer we're trying to get is x plus 2 times x plus 4. So what we're gonna do is we're gonna do 1 times 8. Why 1 times 8? Because that is what tells us, it gives us a clue about these. Because whatever we get, the answer has to be 8. So I'm gonna do 1 times 8 equals 8. And now I'm gonna think of all the things.
Oh no.
Oh,
I hate this thing.
Well, it's not that bad.
Oh my gosh,
What's
she
the problem?
loves the T-chart.
Wait, why are we doing the
Solid.
1 times 8 again?
Because it's giving us a clue.
What?
What if there's like a row size like 3x?
We're gonna do one of those too.
I think it reminded her from that.
Wow. So, what we need is 2 things that multiply to 8, but add up to 6. So all we really have to do is keep trying some stuff. It's not gonna be that bad. 2 things that multiply to 8, and you can go straight through the list. 1 and 8, do they add up to 6? No. All right. 2 and 4, do they add up to 6?
Yes.
There's our pair. You can just go down 1, 2, 3, 4. You don't have to do it fast. You just have to do it. So we found our 2 numbers, 2 and 4. I'm going to rewrite this like this: plus 2x plus 4x plus 8. Here's all I changed. I rewrote the 6x as 2x and 4x. Where did the 2 and 4 come from? Here. Now we're going to split this into 2 groups. This is called reverse FOIL because do you see what we've done? We've gone from here to here. So we got halfway, now we just have to get from here to here. We're going to split this into 2 little groups, kind of in our head. And we're going to take a greatest common factor out of each pair. So, what's the greatest common factor for this pair?
X.
X. And that leaves x plus 2 in here. What's the greatest common factor for this pair?
4.
So that leaves what in there?
X plus 2.
Here's why this method is pretty awesome. Do you see how they both have an x plus 2 in the parentheses? That's our proof that we did this correctly. When they match, you are right. You have done your work correctly. If they don't match, time to go back and check what happened up here because something went wrong. So now all that's left to do is write our answer. 2 sets of parentheses, and in the first set I'm going to write x plus 2. Where did x plus 2 come from? I'm just writing it down. Next, I'm going to write x plus 4. That's kind of the leftovers. Here's what happens. When we multiply this out, remember what we're doing is x times each thing in there, right? X times x and then x times 4. And then 2 times x and 2 times 4. This one kind of went backwards, but you see that that's what it really is. This is the work we did when we FOILed it. Just get undone one piece at a time. And there's it. The first time was crazy. The second time will give you a headache. And hopefully after that it'll start to make more sense. Make some more problems.
No. She screams at everything.
Somebody scared me.
One time I touched her
I
hand.
don't know where it's
I just touched her hand.
I'm going to do one with a number in the front. Are y'all all ready for that? 9x squared plus 15x squared. 9x squared plus 15x plus 4. There are no like terms, and if we can find a greatest common factor, we want to take one out. But there isn't one this time. Alright, now last time I did 1 plus 8 to get, 1 times 8, sorry, to get my number. This time I have to do 9 times 4. So 9 times 4 gives me
36.
36. So I need numbers that multiply to 36, but add up to 15. You can always go right down the list. 1 and 36, 2 and 18, 3 and 12. Found my pair. Some people are very good at just thinking of them without trying that stuff. If you're very good at that, there is no reason for you to write a list of fake numbers and act like you tried a bunch of stuff. You don't have to make up fake work for this. But I'm not good at it. I'm a go in order kind of a girl. So I do 1, then 2, then 3. 4 would be my next factor, just in case that one hadn't worked. 4 times 9, and I would just keep trying until I found the pair that worked. So now I'm going to rewrite this. I keep the 9x squared, but instead of 15x, I will write
Wait, Miss Taylor.
3x and 12x.
plus 3x plus 12x. Those numbers came from here. Because 3x plus 12x is 15, so I haven't actually changed it.
Miss Taylor,
Yes, ma'am.
why did you pick those numbers on the right side of the teacher?
Because that's what gives me the 36. 1 times what? 36. 2 times 18? 36. 3 times 12? 36.
Oh,
I find the numbers that multiply, that's 36.
okay. What if you don't know which number is multiplied to a certain number? You think it's harder?
We usually don't give you huge ones, but if you, if you are not great at doing the factors in your head, which a lot of people aren't, you can just take your calculator and do 36 divided by 1, and write down what it tells you. 36 divided by 2, and write down. And if it doesn't give you a whole number, then you can just skip that one.
Okay.
Like when I get to 5, 36 divided by 5 is something it doesn't, so that one doesn't work. Alright, now I'm going to divide them up into 2 sets. You might be asking yourself, what if I had written the 12x first and the 3x second? Would it matter? You should get the same answer in the end. Your work will look different along the way, but your answer will be the same in the end. So we're going to take out our greatest common factor. What's the largest thing that goes into both of those?
3x.
Oh, good. And then plus
1.
Alright, now cross your fingers, because if we did this right, our next set of parentheses is also going to have 3x plus 1. Beware of, since you know what you expect to get, sometimes you don't pay attention and you write that down, even though it's not really right. So we got to be careful. What's the greatest common factor here?
4.
Okay. So then 12 divided by 4, that's 3x plus 1. Aha! So 2 sets of parentheses. This is really our distributive property. 3x times this plus 4 times this is why we can write it this way. In case you are curious about why we're allowed to go from here to here. Distributive property. So I write 3x plus 4 in one set. What goes in the other set?
3x plus 1.
Okay, I'm so bored, and that is a little bit heartwarming to me because most people think factoring is super hard and I hate it. So if you're bored, we can switch those, right? Yes. The 3x plus 1 could have been here, and the 3x plus 4 could have been here. The order doesn't matter. Yes, ma'am.
How did we get those 4
Which, right here?
No, down
3x
Those
plus
are fun day today. I hate Mondays.
is this it.
It's on the day.
I know.
It's
but it
in
feels like
both,
Monday.
but we only write
I hate
one.
Mondays.
Because if you FOILed this out, what you would do is 3x times that, then 4 times that. So that's kind of what this step is, the 3x times that, and 4 times.
It felt like Saturday the whole day.
We did feel like Saturday, except for I woke up at 6:30,
It's all like,
which made me angry.
They are.
Woke up at 10.
Shut up. I wanted to punch somebody.
It's
So
okay.
I was like,
It's not like I
no.
spent my Veterans Day
No
day.
like terms and no greatest common factor,
I worked all day.
but always ask yourself that.
I went shopping.
I
So
slept in.
since this is a trinomial, we only have one option for how to do it. I'll show you a shortcut in a minute, but I'm gonna be honest, the shortcut is confusing to me. So I'll show it to you, but I still do mine the long way, because the long way isn't that long. Yes, ma'am. I'm probably gonna give you problems. Because the book has, can you go ahead and do it?
I just get the Hopkins Tower in itself.
Oh.
It is
Alright,
not-
the first thing we do is 9 times 16. That's the first and the last, whatever they may be. Remember that if there's nothing there, we treat it as a 1, so we do. Because sometimes once you do a couple with a number in the front, you forget what to do when there isn't a number. That's 1 times 8. So 9 times 16, what on earth is that? This is a case of, aren't you glad Alicia asked that question, because I bet none of y'all could do these in your head. 144. Alright, yay.
12
So,
times 12.
1 and 144.
Oh.
Oh, yeah, she's right, 12 times 12. But what if you're not that good at it like me? You can go through 144 divided by, I just want you to see what has to do if you can't do it in your head. I did 144 divided by 2. 2 and 72 do not give me this. 144 divided by 3, that will be a whole number.
48.
Are you faster on your calculator than me or in your brain?
My calculator, because I just gotta do back to the last one, and I was like,
Well, I'm using this.
oh.
So you would keep trying until you get the pair that add
Oh
up
gosh,
to.
I'm down to
What is
10.
it?
12 and
12.
12 and she had done it.
Man!
Somebody saw it right away. Kaylee, was it you? Who said it? Was it you or just said it? Who said I saw it right away?
That was-
Well, duh!
Alright, so now what do I write in my second line?
12x plus 12x.
So I'll keep the other bit and I write plus 12x plus 12x plus 16. Alright, now I divide them into pairs. What can come out of here? 3x. So I'll have left
3x.
3x plus
4. Yeah.
that x comes out. Alright, what can I take out of there?
4.
So what's left is
3x
3x plus 4. Thank goodness.
Yeah.
When they match, that's your mental, I like when math does this to me, that's our check right there that says we've been doing our work. It is possible to do your work wrong and still get matching pieces, but that's pretty rare. Even when there's, and that's right,
Whoa, they're the same.
If you want to look real fancy, you could write it like this.
3x plus 4 squared?
Yeah. What do you think? How terrible is it?
Once you taught me that
Just 'cause it's
dividing
first
way with the factors, I got it.
Aren't you glad you asked the question? I love a good question.
We have math class.
Yeah.
Oh wait, now that's third period.
Yeah, it's real hard.
No, but we gotta count. All of my classes are now classes.
Except Miss Williams.
Oh, that's true.
Been-
Alright, what makes this one different from what we've been doing?
Negative 32.
That's what makes this one different from what we've been doing. Negative? The negative in there.
So is it positive 8, negative 4?
2, okay.
You did 1 times negative 32.
Negative.
That means our signs have to be different. That's all it
Oh
means.
no.
It just means our signs have to be different. As far as the work goes,
Don't.
as far as the work goes, we can kind of still do it the way we were doing it. We just have to look at each one a little more carefully. 1 and 32 gives me 32. Right?
Would you
Would
need
it be
to put
better
But when I
it?
subtract, and the question is where do you put the negative, and we'll work on that in a minute. So just because we get different signs, know that that means we're going to have to subtract. Okay, so 32 minus 1, not 4. So let's try another one. 2 and 16. 16 minus 2, not 4.
It's gonna be a long time.
3 and, doesn't go in there evenly, does it?
Negative.
4 and 8. There's our pair, because 8 minus 4 is 4. So what's different about this one is that instead of adding up to a certain thing, they subtract to a certain thing. So we have 8 and 4. So when we write this, we're going to be careful that we put the minus sign on the correct one. So what we do is look at our answer. We need to get positive 4. So which one needs to be bigger? It needs to go positive 8, negative 4.
And why is that?
Because 8 is bigger than 4, we need our positive to be. When you put them together, they have to come out to positive 4.
Gotcha.
Is that?
Yeah, that makes sense.
So you just carefully look at them and see which one needs to get the positive to make the answer come out to that. But from there, we're basically going to do the rest of the thing. So I'm going to do, what can I take out of here?
X plus 8.
All right, now out of here, I can take out a negative 4. So that leaves X plus. So my two things are, all right. It's not too much work. It just means you're going to have to subtract them instead of adding them.
Where do you put the sign?
I did, the X plus 8 came.
No, where do you put your signs on your T-chart? You said we're going to go over that.
I don't. 'Cause I don't worry about figuring out the sign until I get to
You just subtract them. Anyway.
Yes, ma'am.
Does it matter which order that you do?
No,
Okay. Cause like on the other ones, the X is
it doesn't matter. So you could have put X minus 4 on there. That, ladies and gentlemen, is which property? Commutative property. So you didn't know. The commutative property says it doesn't matter which order you put two things that you're multiplying. So, when this sign at the end is positive, we're looking for two numbers that add up to whatever. When this one is negative, we're looking for two numbers that subtract to give us this. The sign of this number is just going to affect what we do right here.
Was that our homework?
Alright, this time I'm going to show you the
Just
shortcut.
give me a miniature
That's
cul-de-sac.
shown to me by Miss Brazel. It's been shown to me
Wait,
like
was
4
that-
times and it confuses me every time. Can't you take
Not the full 3 pager, but I can make it so
Jessica.
better if I can 1 pager.
Can we just high five? I'm coming all the way back.
Stupid. Are they coral out?
This is crazy. I don't know why.
I guess it was flying, and mine was flying, and he's trying to shoot it, but he
Yeah,
missed
turned
it.
into her. This is how I learned it.
Of the weather.
Wait, this is short way?
Short
way?
The long way and then the short way so you can see how they go
It
together.
shoots the bride of
But
the
I'm going to be
shore.
honest, if you don't understand it, the shortcut can make you shoot it.
I don't want to learn it.
But it's not too bad.
The captain,
It
and mine,
confuses me, but I'm easily
the
confused.
captain trusted.
All right, so I took out a 3, that's the first thing I
bride
did.
of a wedding.
Now I need two things that multiply to give me negative 30. Because 1 times negative 30.
But is this the same thing?
I'm going to do it the long way, and then I'm going to show you the shortcut. Because I want you to see how they go together. I took out a 3 first, that's what made it different. This one did have a GCF, so but for now I'm ignoring the 3 and just doing that part. So two things that multiply to 30 but subtract to 1. So it is not 1 and 30, and it isn't 2 and 15. It's not 3 and 10. 4 doesn't go in there, 5 and 6. There they are. When you rewrite it, I'm just kind of keeping that 3 so I don't forget about it.
Negative 1, so what you got?
So it's gonna have, the minus is gonna have to go on the 6. Because negative 6 and positive 5 is the same. So the larger of the numbers has to be
We have to close
negative
the
to give me that
parentheses.
negative answer. Close my parentheses. Thank you. Did somebody say that? I thought I heard it. Alright, but now I'm gonna have, oops, now I'm gonna take out my GCF. Out of here I can take
Yeah.
X. And out of here I can take 5. I'm not going to forget my 3. And I'm going to write
X plus 5, X minus 4.
yeah, except I did it wrong.
In the opposite order, right? Yeah.
Okay. Here we go. If we want to do it by the shortcut, we still have to make this little T-chart. That's why it's called modified T. It comes from that little, and it's called a T-chart, I think, for obvious reasons. The giant T, which in our house is T for Tim. Okay, so we do our T-chart the same way, and then we figure out where the minus would have to go. And we figured out it has to go on the 6 because this number is negative. So the big number has to be negative.
Oh.
Alright, now, here's the part where I almost always do it back. Okay, you do. I should have done one in the front.
I think it's be like over 3 or something.
You put the 3 over it. No. Here's what we factored, right? If the 3 is confusing this a little bit, and now I realize this was a bad one to do. Because for now we're ignoring the 3, because what we're talking about is this thing. Does that make sense? So we're ignore the 3 for now and look at the number that's in front. It was a 1, right? 1x. So you do 1x over 5 and 1x over negative 6. 1x because it was the number in the front. The problem with this is it doesn't make sense to me. You just follow it.
Oh, it's a shortcut. Okay.
Okay, and then you try to simplify that fraction if you can. Neither of these fractions can be simplified, so that's our answer. X plus 5 and x minus 6.
Whoa.
But then you have to put your 3 still or not? The 3 was just kind of hanging out. So let's go back and look at another one. I want one with the number in the front, okay? Take a look at this one. Do you remember what our two numbers were? 3 and 12. So what we would do is take that 9x, because it's in the front, and you put it over 3, and then that 9x goes over 12. Then you see if you can simplify your fraction.
How does this not make sense to
I think
you?
that's the way I learned it. Right? Because it can, do you see how much effort I'm going slow because I'm thinking about every word I say.
It's so easy.
So we get 3x plus 1 after I simplify that fraction. 3x, and then it was a 1 on the bottom. This one, what goes into both of them? 3? So that gives us 3x plus 4, which is the same thing we got that way.
Miss Taylor. So much easier.
Look, I showed it to you, didn't I? I could have been like, it's confusing me, so I'm not doing it. But I didn't. Was it okay? It's supposed to be a lot later on. Okay, that means all we have left to do is grouping, well then solving the questions, and I promise that's easy.
And quadratic formula, right?
That's kind of it solving the equation. So, grouping, which is under the 4, when we get there, I told you it would be easier. Because it's basically this step. And that's another one of the reasons I teach this. It'll have 4 terms, but we already did that when we did this. So it's gonna, when we do grouping, you'll say, did we do that yesterday? And the answer will be, sure, yes. And then we'll solve equations, which is where the quadratic formula comes in, but it's not bad either. This was the hard lesson. How you feel? Good? Super good. Alright, let's do some more. Okay, what problems we have? The book. Here's what I don't like about the book at all. They don't mix them up. Each section, it's like there's a section on different squares, a section on sum of cubes. And it doesn't teach you how to figure out which one's which. And then you get on the test and you go, wait, which one was I using? So I don't like the book problems for this chapter.
And you're right, really.
Because it doesn't mix them up. So I have mixed up confused and confused.
Yeah. Yeah.
I didn't count how many it was, but it's not. creative when I write that one. I mean, that's not bad. Graph paper or regular?
What's the answer on number 4?
What's the
It's kind of on the.
4? That's a good 4. That might be the ugliest one ever. Not have a GPS.
I don't know what you do.
Yeah, it is.
It has 3.
Nice, that's where you're stuck then. No, I got it. What you got left? Wait,
That's what
you
I
got a
have.
-3?
You can't.
Is that fine?
And then you just get positive and minus and.
No, for the 27, there's no negative.
But then,
Minus
oh, so then
negative.
it'd make it a -9 and then it'd be a difference in square.
Yeah.
Then positive. Okay.
What? Take out a -3 instead of a +3 when you do your GCF.
Is that on that last one, is there -4Z or -42, because you didn't cross it?
-4Z.
Cause all the other ones are Z.
So would it be?
So it would make
If you
sense.
take out that,
I did, that's a good point, that's why I crossed them.
I always cross mine.
if you take out that,
You get negative.
that -3, what would your 27 boil down to?
2.
7 divided by 3 is 9.
Would it not be -9?
Because you took out the negative.
You get negative.
Was it that a sum of squares?
That's why you take out a -3, and that makes it a difference.
What? Oh, so is it supposed to be that?
Instead of using 3 as a GCF, take out -3.
I did
Oh,
take,
so
I
that would
did
make
take
it
out
ugly.
-3.
So then it will be, is that 9a squared? No, 4a squared
I don't know anymore.
minus 9.